Okay, for this example, I've just modified the problem that we did before. I kept the left-hand side of our differential equation exactly the same, but I changed the right-hand side. In the last example, it was e to the negative 5t. Now it's e to the negative t. Okay. So the associated homogeneous equation is exactly the same, and we did the work to solve that last time. So my solutions to the associated homogeneous equation are still just a e to the negative t plus b e to the negative 3t. We're going to need a new particular solution because we have a new forcing function. And here, the tricky part is that that is a solution to the associated homogeneous equation. Okay, that would be what I get if a is 1 and b is 0. Okay, so there's no multiple of this that could possibly be a solution to this differential equation, because if I plug a multiple of e to the negative t into the left-hand side, I'm always going to get 0. Okay. So we're going to modify our guess, and we're going to do the same thing that we did when we had a first-order situation like this. I'm going to guess that instead of just having e to the negative t, I have t times e to the negative t. So I'm going to guess that I have some multiple of t times e to the negative t, and my goal is to find a value of a that will make that work. Okay, so yp prime, I'm just doing product rule here. So derivative of a times t would be a times e to the negative t plus at times the derivative of e to the negative t, which is going to be negative, so I'll just bump that negative up front, e to the negative t. Okay. So there's my first derivative, and this suggests why it could work. This gives me some e to the negative t's, which I know I want to have. It also gives me some t e to the negative t's, but I know that those are showing up in my particular solution, because that's what I guessed for it. Okay. All right, so let's take a look at yp double prime. That would be negative a e to the negative t minus, and I'll come back and distribute that negative in a moment. Okay. The derivative of at, once again, is just a times e to the negative t plus an at times this derivative, which will make that negative e to the negative t. Okay. So if I distribute the negative, I've got negative a e to the negative t minus a e to the negative t plus at e to the negative t. Notice that's negative 2a e to the negative t plus at e to the negative t. Okay, so we've calculated our first and second derivatives. Now let's plug in and solve for a. So I want yp double prime plus 4yp prime plus 3yp to equal e to the negative t. Now you'll notice on this side there are no t e to the negative t's. All that means is that however many I get over here has to be 0. They have to all cancel out. Okay, so yp double prime, we said that was negative 2a e to the negative t plus at e to the negative t plus 4 copies of yp prime, that was a e to the negative t minus at e to the negative t plus 3 copies of y sub p, that's going to be 3at e to the negative t. I am running out of board space. So I'm just going to remind myself off to the side here that y sub p was at e to the negative t. And we've plugged in these derivatives, so I don't need that information anymore. This was my left-hand side. I want that all to equal e to the negative t. Okay, so let's do some distributing and consolidate some terms. Negative 2a e to the negative t plus a times t e to the negative t plus 4a e to the negative t minus 4at e to the negative t plus 3at e to the negative t has to equal e to the negative t. So let's consolidate our terms. All of these terms on the left are either e to the negative t's or t e to the negative t's. So let's see, that's some e to the negative t's, that's some e to the negative t's. Looks like that's it. So I've got negative 2a plus 4a, that's a total of 2a e to the negative t. Plus, I'm going to have some number of t e to the negative t's. Okay. So looks like here I've got a of those. Here I've got negative 4a of those. And here I've got 3a of those. And all of this has to equal e to the negative t. How nice is that? A minus 4a plus 3a is 0, so that does drop out. We said there were no t e to the negative t's over here. They were going to have to drop out. They just did. So I need 2a e to the negative t to equal e to the negative t. That's going to, of course, work if 2a is equal to 1, so a would equal 1/2. So now I know that my particular solution is 1/2 t e to the negative t. Add that to the solution to the associated homogeneous, which we'd actually already solved for in the previous problem, and that gives me my general solution.